Imagine unleashing the power of creative destruction within your 3D world. Hi, in this explosive tutorial I will show you how to breathe life into any 3D model, turning it into a mesmerizing spectacle of destruction and rebirth. We'll learn how to prepare models in Blender and animate their explosion based on the page scroll. Let's start by setting up our React 3 Fiber project. Go to the GitHub repository, code, and copy the address. In a terminal, run git clone, paste the address and name the folder you want to put it into. useExplode. When it's done, we open the folder, we run a yarn and yarn dev. We can click here to preview it. You should now see this cube and being able to rotate around. To get free 3D models we can use in our project, go to poly.pizza. Let's search for heart, take the one from Quaternius and hit download and download GLB. Now let's jump into Blender. Hit File, New, General and A to remove everything. Then File and import the GLB file that we just downloaded. It's in Downloads, heart.glb, import GLTF 2.0. We can now see the heart here. Maybe it's a bit too small. Let's go on the heart. Tab, open edit mode. A to select everything. Let's scale it up a bit so it's more visual. Let's go back to object mode. On this model, what we want to do is to fake an explosion by separating it into specific meshes. We need a plugin to do that. Go to Edit, Preferences, go to Add-ons, and search for Cell Fracture. If you don't have it check it. Now, when you are on the mesh, in Object Mode, so Tab and Object Mode, go to Object, Quick Effects, and Cell Fracture. You can play with the different settings, like the noise, or what it is affected to, but I didn't have very different results. So you can run it with the same parameter than I have or the default ones and run OK. Now you can see we have our original heart separated into a lot of different meshes. If we take anyone here and we move it, it's a part of the mesh that we removed. But we don't see a hole when we move it. It's because we have all the new cell that has been created, but also the original heart that is still here. If we hide it, and we go to a cell and move it, now you can see a hole. But for the system we want to put in place, we will keep all the cells and also the original model. We will just rename Heartful into Origin. This way we will be able to hide it or make it visible. Now our model is ready. We just have to do File, Export, GLB GLTF. Inside our project we go to the public folder. We create a new one named Models. And inside we will put heart.glb. The format has to be GLB. We can also add some compression. React 3 Fiber will automatically decompress it and go export GLTF. Now we have the model in our project. We can stop the development server and run npx gltf jsx with the model we created, so heart.glb, -o for the output folder, source components, and let's name it heart.jsx, and -r for the root directory, and it's public. We can restart the development server and hide the terminal. Now, if we go into components, we can see we have our heart generated. We will just rename it heart. And also let's have a look if we have the original one. Oh, I didn't keep the name, so we need to regenerate it. So go on the terminal, stop it, rerun it, and hit -k. Now we can restart yarn dev. And in our component, we need to reopen it because we change it, heart. Now we have the name of each mesh, and we have the mesh name origin. This is what we will use. We can rename the component heart, save it, go to experience, and replace the default cube with our heart. We can also add environment component with preset sunset. And to have a background color, what we can do is add the background component, but to blur it a lot, to use the image blur to create a gradient background. So far, this is what we have. We can change the scale and move the camera. To move the camera, we go into App. We set it 0, 0, and 5. And to scale down the heart, we can just go into it. Scale equals 0.5 by half. Let's look what we have. Maybe it's a bit too big. 25, a quarter. Okay, it's not that bad. And you can see we have a nice gradient background when we rotate around. For staging purpose, we can also wrap the heart into a float component and add float intensity of 2 and speed of 3. Now we have our heart floating in the air. Let's see how we will do this explode effect. We have our heart. I'm a very good drawer. It is split into a lot of pieces and it has a center in the middle. It's the position 0. If you look into Blender, you can see the center, this orange dot, is correctly placed. We will calculate the vector between the center and the position of the mesh, and we will use it to spread our explosion. Now we know the logic, let's try to implement it. We want to react on scroll, so we will add the scroll controls to have a scrollable zone. We'll add 4 pages, it's just a random number to have enough distance to be able to scroll. And then in experience on orbit control, we need to remove the zoom or we won't be able to scroll. Enable zoom false. Now we can see on the right we have a scroll bar. We can now use it to create our vector to explode our heart. Go to heart, we will need a reference to the parent group. Const group is equal to useRef, and we attach it to the main group. Ref equal group. Then we will need on each mesh to calculate the direction to the center. To be able to do it at the beginning, we will use useEffect. We will iterate through each object of the group, group.current.children.forEach. And for each mesh, it's not always mesh, just a 3D object, but let's call it mesh. As it's JavaScript, we can add new properties to our object. So mesh.originalPosition, I know it doesn't exist, so I can do it, is equal to mesh.position.clone. So we are getting the initial position of this mesh. Now to calculate our direction vector, we'll need the word position of it if our object is not perfectly centered. So const mesh word position is equal to new 3.vector3. We need to import a 3. Now we can do mesh.getWordPosition on meshWordPosition. Now in meshWordPosition, we have the word position of this mesh. We also need the group word position. As it's always the same group, we can do it before the loop. Const group word position is equal to new 3vector3 and group.current.getWordPosition on group word position. The orange dot here is the group word position. And here, if I draw like in green, this is the mesh word position. And the blue line, we want to calculate it. We will store it into our mesh. We will name it direction vector is equal to mesh word position dot clone to not alter the actual position dot sub group word position. And we also want to normalize it so the distance doesn't impact our result. Now on our mesh, we want to store the target position when we have scroll entirely. It will be mesh.originalPosition.clone, and we will add the mesh.directionVector.clone, and that we will multiply by a distance. We can change it later, but let's say 3 for the moment. Now our mesh are set up, we need to use useFrame to animate it based on the scroll. What we will do is we will iterate through all our meshes like we did before in the useEffect. And on mesh.position.x, it will be equal to 3.mathutils.lerp. And the start value, it will be the mesh.originalPosition.x. This is why I'm not lerping directly the position, but I use three.matUses, so I can define the start value. And mesh.targetPosition.x. And the third parameter is where I am closer. Let's get the scroll data. Const scroll data is equal to use scroll. And we will use scroll data dot offset. So it's 0 at the beginning of the scroll and 1 after scroll. This way we always have a value between the original position and the target position. Okay, now we need to do the same on the y axis and on the z axis. Okay, now if we scroll, we can see that the heart explodes, we can go back and forth, but we still have the heart inside. Maybe you want to keep it, but maybe you don't want. If you don't want to keep it, we can do if scroll data dot offset is below 0.0001, like a very low value, maybe this, then we will check the mesh name because we kept it. We said if it's origin, currently it's almost 0, so we will display our mesh. If it's not, we will not display this mesh. Now we have to do the opposite. So if we are over scroll data.offset, if mesh.name is origin, we hide it, else we show it. Now here we only see the original mesh, and when we start scrolling, we don't see the original and we see the pieces of the mesh. Let's see how to make it generic for other objects by creating a hook, and also how to apply it to other objects and add rotation. By the way, when you use GLTF JSX, usually you already have the copyright info here. But here it's not the case, maybe because we import it into Blender and re-exported it. A good thing to do is go to Polypizza, copy the link here, and in the comments of your component, give the credits to the author of the model. Okay, we can go back to Polypizza and search for our banana. I will take this one by Poly by Google. Download GLB. On Blender, I can delete everything or start a new project, it's up to me. File, import, GLB. I found my banana, import GLTF. It seems it's very big, maybe I can zoom out and scale it down. Now, just to show you, currently this banana, the center is correctly placed, but maybe you have some models where it's like this. It's not in the center, so you won't be able to calculate the distance and everything. An easy way to do it is go to Object, Set Origin, Center of Mass Volume, and now you see the orange dot in the middle of the object. So you can move it anywhere you need. Now, like we did before, Object, Quick Effects, Cell Fracture, OK. And we have the pieces of our banana. We scroll down, where is the original one? Maybe it's this one? Yeah, it seems so. We rename it Origin. Now we can export it, File, Export GLB, and name it banana.glb. As I didn't kit, I still have my compression. Export. Now in the terminal, let's stop the development server, run it again on banana and banana model. We can open our banana component, rename it to banana, be sure that we have the origin here, and it should be fine. We can go full text link, copy for the credits, and paste it here. Now in our experience, we will use leva to switch between the banana and our heart. We need to install it, yarn add leva, yarn dev and hide it. Const item is equal to use controls. We will have item, the value it will be heart by default, and the options is either heart or banana. Okay, Now, instead of conditional rendering, a good optimization to do is to play with visible. So is our item heart, and for banana, visible is equal to banana. Okay, we have the heart and the banana, but it's way too big. Let's try 0.15. It looks better. Now, instead of coding the logic into our banana, we will create a hook. Inside source, we will create a new folder named hooks. New file, useExplode.jsx. To create our hook, we will do useExplode is equal to a function. And the parameter it will take will be first the group on which we want to apply it, and an array of options. By doing so, we can add default value. So distance will be 3. Enable rotation will be true by default. And now we can code the logic of our useExplode. We won't have to code a lot because we have done everything in the heart. We can copy the use effect and the use frame in useExplode. Okay, now we need to do the necessary import on use effect, use frame, and use scroll. So it requires you to be inside a scroll container. Then here, instead of multiplying the scalar by 3, we will use the distance. But to not cause issue when we will change the distance, we can separate it. We will do another use effect on the distance, and we will calculate the target position only in that case. So this one is just to calculate the target position, and we don't need to do it anymore here. Before adding the rotation, let's try to use it on the banana. We need to export the useExplode, save, go to banana. We will need the group. It's equal to useRef. We need to assign it to the parent, ref equal group. And now we can simply use explode with the group. And we can keep it like this, but we can also set the variable like a different distance, let's say 8, and enable or disable the rotation. We won't set it, it will be true by default. And we have a beautiful error because we don't have 3 defined. In useExplode, import 3. Okay, the heart is still working, we didn't connect the useExplode. And if we go to the banana, we can see it. And if we scroll, we have the banana exploding. What if we just change the distance? Maybe we set it to 1. If we reload, we have the banana exploding. Let's put back the banana distance maybe to 6. useExplode, let's add the rotation. On our setup use effect here, we will store the mesh.originalRotation. It will be mesh.rotation.clone. And we will do a target rotation that will be math.random multiplied by math.pi. We will do that on the 3 axis, so it's half a circle rotation. Here we can do it even if it's disabled, so we don't have to recalculate it later. But in the use frame, we'll need to add if enable rotation. Then we just have to hit tab if you have GitHub Copilot. Well, what it does is it's on the rotation X, it's exactly the same than on the position. We lerp from the original rotation to the target rotation based on the scroll data.offset. Now let's look at our banana. When we scroll, you can see that the pieces are exploding and rotating. Now you can try to download 3D models and to apply useExplode to those models. Thank you for watching, I hope you enjoyed this video. If it's the case, please hit the like button as it really helps the channel be more visible to other fellow developers. Don't forget to subscribe to not miss the weekly tutorial. I also start to have a lot of video tutorials available. If you want to continue learning, I recommend you this video here.